Hello everyone, I hope you guys are doing extremely well. Today we are going to discuss another problem in our binary search tree series. The problem name is Inorder Predecessor in binary search tree. So let us understand the problem description first. So we are given the root node of a binary search tree and we want to find the Inorder Predecessor of every node in BST. So this problem is similar to the previous problem that I have explained you. In that problem, I have explained you the Inorder successor in binary search tree. In this problem, we will be understanding the Inorder predecessor. So let us understand what is Inorder predecessor. So Inorder predecessor of a node is the previous node in Inorder traversal of the binary tree. Now the first node is gonna have the Inorder predecessor as null. So let us take an example to understand this more clearly. Okay, so let us say we are given the root node of the binary search tree as node 25. Now the left child of node 25 is, let's say, node 15 and the right child is node 35. Now the left child of node 15 is, say, node 5 and the right child is node 20. Now the left child of node 35 is null and the right child is also null. So let us find the Inorder predecessor of every node. So how can we do that? So let us first find the Inorder traversal. So how can we find the Inorder traversal? We can start from the root node and we'll go to the left. So for node 25, what is the left subtree? The left subtree is node 15. So we'll reach at node 15. Now for node 15, is there any left subtree? Yes. So we'll reach at node 5. Now for node 5, there is no left subtree. So now let us add this node 5 in our Inorder array. So this is our Inorder array and we have added this node 5 here. Okay, now is there any right subtree for node 5? There is no right subtree for node 5. So we simply gonna return. Now for node 15, we have processed the left subtree. Now we are gonna process the node. So we are gonna add this node 15 in our Inorder array. Okay, and now we are gonna process the right subtree of node 15. So the right subtree of node 15 is node 20. We'll reach at node 20. For node 20, what is the left subtree? The left subtree is null. Now we are going to process the node. So we are going to add this node 20 in our Inorder array. So 20 will be added here. Now, is there any right subtree for node 20? There is no right subtree for node 20. So we simply going to return. Now for node 15, we have processed the left subtree, we have processed the node, and we have processed the right subtree. So we simply going to return. Now for node 25, we have processed the entire left subtree. Now we'll process the node. So we'll add 25 in our Inorder array. Okay, and now we are going to process the right subtree. So we'll reach at node 35. Now for node 35, is there any left subtree? There is no left subtree. So we are going to process the node. So 35 will be added in our Inorder array. Is there any right subtree for node 35? There is no right subtree for node 35. So we simply going to return. Now for node 25, we have processed the left subtree, we have processed the node, so we have processed the right subtree, so we simply gonna return. And this is the Inorder traversal of the binary search tree. Now what is the predecessor, the Inorder predecessor of every node? So for node 5, what is the Inorder predecessor? For node 5, there is no previous node, and we can clearly see the Inorder predecessor for the first node in Inorder traversal is null. So for node 5, the Inorder predecessor is null. Now for node 15, what is the Inorder predecessor? So it is the previous node which is coming in the Inorder traversal. So it is nothing but node 5. Node 5 is the Inorder predecessor of node 15. Now for node 20, what is the Inorder predecessor? The Inorder predecessor is node 15. So for node 20, the Inorder predecessor is node 15. Okay, now for node 25, what is the Inorder predecessor? The Inorder predecessor for node 25 is node 20. Now for node 35, what is the Inorder predecessor? The Inorder predecessor for node 35 is nothing but node 25, because 25 is the node which is the previous in Inorder traversal. So what we are going to return? We are simply going to return all the Inorder predecessors. So first value will be null. The next value will be node 5, the next value will be node 15, the next value will be node 20, and the next value will be node 25. So we are gonna return an array of Inorder predecessors. So this will be our answer array. I hope the problem statement is clear. This problem is totally similar to the previous problem that I have explained you. In that problem, we talked about the Inorder successor. In this problem, we are talking about the Inorder predecessor. So let us quickly understand how we can solve this problem. Okay, so let's take an example. Let us say the root node of the binary search tree is node 37. Now the left child of node 37 is, let's say, node 27, and the right child is node 47. Now for node 27, let us say the left child is node 17 and the right child is node 35. Now the left and the right child of node 47 is null. Now for node 35, the left child is, let's say, node 32 and the right child is node 36. Okay, we want to find the in-order predecessor of every node. So how can we do that? So the first approach is pretty clear. We can find the in-order traversal of this binary search tree. Once we have find the in-order traversal of this binary search tree, we can just traverse that in-order array, and for every node, the previous node will be our answer. So let us quickly understand how we can do that. So we are going to start our in-order traversal from node 37. From node 37, we will reach at node 27 because we process the left subtree first, then the node, and then the right subtree in an in-order. So for node 27, we are again gonna reach on its left, so we'll reach at node 17. For node 17, there is no left, so we are gonna process the node. So 17 node will be added in our in-order array, right? And now, is there any right subtree for node 17? There is no right subtree for node 17, so we'll reach at node 27. Now I have already made a video on how to find the in-order traversal using recursion and without recursion as well, so I will request you guys to please look at those two videos first to understand in-order traversal in depth. So now for node 27, what is left to process? The node. So now we are going to add this node 27 in our in-order array. Okay, now is there any right subtree? Yes, the right subtree of node 27 is node 35, so we'll reach at node 35. Now for node 35, is there any left subtree? So we'll reach at node 32. Now for node 32, is there any left subtree? No. So now we are going to process the node. So 32 node will be added in our in-order array, right? Now we are simply gonna return, is there any right subtree? No. So we simply gonna return. So we'll reach at node 35. Now we are gonna process the node 35. So 35 node will be added in our in-order array. And now we are gonna process the right subtree for node 35. So right subtree for node 35 is node 36. So we'll reach at node 36. Now, is there any left subtree? There is no left subtree for node 36. So now we are gonna process the node. So 36 node will be added in our in-order array, right? And is there any right subtree? No. So we are simply gonna return from here. Now for node 35, we have processed the left subtree, we have processed the node, we have processed the right subtree. So we simply gonna return. Now for node 27, we have processed the left subtree, we have processed the node, we have processed the right subtree. So we simply gonna return. Now for node 37, we have processed the left subtree. Now we are processing the node. So node 37 will be added in our in-order array. Now, is there any right subtree for node 37? Yes. So our recursion will reach at node 47 now. Okay, for node 47, what is the left subtree? Null. Now we are going to process the node. So node 47 will be added in our in-order array. Now, is there any right subtree for node 47? There is no right subtree for node 47. So we simply going to return. Now, we have processed the left subtree for node 37, we have processed the node, we have processed the right subtree. So we simply gonna return, and that's it. This is nothing but the in-order traversal of our binary search tree. So once we have figured out the in-order array, what we can do for every node, for the first node it will be null. So for node 17 it is null. Okay, now for starting from the second node, that is from node 27, what is the in-order predecessor? It is the previous node. So for node 27, what is the in-order predecessor? It is nothing but node 17. Now for node 32, what is the in-order predecessor? It is the previous node. It is the node 27. So for node 32, it is nothing but node 27. Now for node 35, what is the in-order predecessor? It is node 32, because 32 is the previous node in in-order traversal. So 32 is the answer for node 35. Now for node 36, what is the in-order predecessor? It is nothing but node 35. So for node 36, the in-order predecessor is node 35. Now for node 37, what is the in-order predecessor? It is nothing but node 36. So for node 37, the in-order predecessor is node 36. Now for node 47, what is the in-order predecessor? The in-order predecessor for node 47 is node 37. And that's it. Now in the end, what we are going to do, we are simply gonna make an array of these values. So it will be null, then 17, and then 27, and then we have 32, and we have 35, and 36, 37. So this is our in order predecessor of every node. Okay, and that's it. This is what we want to return. So how can we do that? We have already done this. We just figured out the Inorder Traversal. We have just processed the Inorder array, and that's it. We have got the solution. Now talking about the time complexity of this approach, the time complexity of this approach will be big O of n to find the Inorder Traversal, that is to fill up the Inorder array, and once we have done that, we are gonna iterate over the array as well. So big O of n extra, because we are iterating. So the overall time complexity will be big O of 2n, which is nothing but big O of n. Okay, now talking about the space complexity, the space complexity is big O of n because we are creating an extra array for Inorder Traversal. So space complexity is big O of n, where n is the number of nodes present in this binary search tree. This problem is very good, very good, but we are doing two traversals of the binary search tree. Firstly, we are finding the Inorder array, and then we are traversing this Inorder array. So we are doing two traversals. Can we solve this problem in one traversal? Yes, we can. I have already explained you that in Inorder Successor. So we are gonna use the same logic to solve here as well. So let us understand that as well. Okay. So let us take an example. Let us say the root node is nothing but node 77. The left child of node 77 is node 67, and the right child is nothing but node 87. Now for node 67, the left child is node 57 and the right child is node 70. Now for node 87, the left child is null and the right child is node 97. So what we are going to do, we are simply gonna do an Inorder Traversal. In the previous video, we have done the reverse Inorder Traversal to find the successor, but we want to find the predecessor. So we just need to do a simple Inorder, and we don't need to store that. We are just going to use a variable called temp. So initially temp will be set as null. Okay, temp is nothing but null. Now we are going to start our Inorder Traversal from the root node. So for node 77, we are going to start from here. And now, is there any left subtree for node 77? Yes. So in Inorder Traversal, we process the left subtree first, and then we process the node itself, and then we process the right subtree. Okay, so what we are going to do, we are simply going to say for node 77, is there any left subtree? Yes, the left subtree is node 67. So from 77 we reach on node 67. Now for node 67, is there any left subtree? The left subtree is node 57. So we'll reach at node 57. Now for node 57, is there any left subtree? No. So now we are going to process the node. So how we are going to process the node? So firstly, we are going to store this temp in some answer array. So we are going to store this null in an answer array, and after this we are going to change this temp to the current node. So temp will become node 57 now. That's it. We need to do things. Firstly, store temp store, and then change temp. Okay, then change temp. Okay, is there any right subtree for node 57? There is no right subtree for node 57. So we simply gonna return. So we reach at node 67. Now for node 67, the left subtree is node 57. We have processed it. Now we are gonna process the node. So what we are going to do, we are going to add this value of temp in my answer array. So node 57 will be added here. And now we are gonna change our temp to current node. So it will become node 67. And now we are going to process the right subtree of 67. The right subtree of 67 is node 70. So now our recursion will reach at node 70. Now for node 70, is there any left subtree? There is no left subtree. So now what we are going to do, we are going to process the node. So how will we do that? Firstly, we are going to store this temp in our answer. So this 67 will be stored, and now we are going to change this temp to the current node. So it will be changed to node 70. Okay. Now, is there any right subtree for node 70? No. So we're simply gonna return from here. Now for node 67, we have processed the left subtree, we have processed the node, we have processed the right subtree. So we're simply gonna return. Now for node 77, we have processed the entire left subtree, and now we are gonna process the node. So how can we do that? Firstly, we'll add this temp value. So node 70 will be added here, and now we are gonna change this temp to the current node. So it will become node 77. And now we are going to process the right subtree. So node 77 right subtree is node 87. So our recursion will reach at node 87 now. For node 87, is there any left subtree? There is no left subtree for node 87. So now we are going to process the node itself. So how can we do that? Firstly, we'll add this value of temp in my answer array. So 77 will be added in our answer array, and then this temp will be changed to current node. So it will be changed to node 87. And now we are going to process the right subtree for node 87. The right subtree for node 87 is node 97. Okay, So our recursion will reach at node 97. Now for node 97, is there any left subtree? There is no left subtree for node 97. So now we are going to process node 97. So how will we do that? Firstly, we are going to store this temp in my answer array. So 87 will be stored here. And now we are going to change this temp to current node. So it will be updated to node 97 now. And now we are going to check, is there any right subtree? There is no right subtree. So we simply going to return. For node 87, we have processed the left subtree, we have processed the node, we have processed the right subtree. So we simply gonna return. For node 77, we have processed the entire left subtree, we have processed the entire right subtree. So we simply gonna return, and that's it. In the end, the values corresponding in my answer array will be my final result. And as you can clearly see, let us do the Inorder Traversal to verify our answer. Okay, so the Inorder Traversal of this array will be nothing but, let us just quickly do it. So it will be 57, and then it will be 67, then 70, and then 77, and then 87, and then 97. If you are observing one thing, that Inorder Traversal of a binary search tree is always gives us a sorted array. So this is a property that we are going to use in upcoming problems. So remember this, that Inorder Traversal of a binary search tree will give us a sorted array. So for node 57, what is the Inorder predecessor? It is nothing but null, because this is the first node. For node 67, what is the Inorder predecessor? It is the previous node, so it is node 57. And as you can clearly see, the second entry is node 57, the first entry is null, so on and so forth. This is how we can verify. But we have finally figured out our result, and as you can clearly see, we have done only one traversal. We have not done two traversal, we have done only one traversal. So talking about the time complexity, the time complexity is big O of n, where n is the number of nodes present in BST. Talking about the space complexity, the space complexity is constant because we are just using a temporary variable. But if we are considering the extra space used in constructing our answer array, so it will be big O of n. But if we are not considering this return answer, then it will be big O of 1. So whatever the interviewer wants, you can explain to him that this is our time complexity and this is our space complexity. I hope the solution approach made sense to you guys. Now we are going to understand how we can implement our logic in the form of code. So let's do that as well. So as you can already see, I have already declared a function called Inorder Predecessor that is taking the root node as an argument. Now root node is nothing but an object of class tree node. I have already explained you in previous videos that what is this class tree node. It is nothing but having a constructor that is initializing the value of the node. The left and the right child of any node is by default set as null. Now what is the first thing that we need to do? First thing that we need to do is to declare an answer array. Initially it will be empty. The second thing is to declare a temporary, that is a global variable. So how can we declare a global variable? I'm just gonna declare it using an array so that I can pass this temp variable in my recursive function calls. And now we are going to do an Inorder Traversal. So Inorder Traversal. Okay, in this we need to pass the root node, the temp array, and the answer array. Okay, now after this I just need to return our answer array. Okay, now we need to write this Inorder Traversal, which is pretty easy. I have already explained you hundreds of times. So root and then temp and then answer. So what is the first thing that we need to check? If the node that I'm currently on is null, so if root is null, in that case we can't do anything, so we just need to return from here. Okay, now what is the second thing? The second thing is to process the left subtree. So let us process the left subtree. So Inorder Traversal root.left, pass temp into it, and then answer. Now once we have processed the entire left subtree, now we are going to process the node of, okay, so how can we do that? What we need to do, answer.append temp of 0, because temp of 0 is going to give me the value, and then temp of 0 will be updated to current node, that is temp of 0 is equal to root. So how we have processed the node? Firstly, we have added the value, whatever the value present in the temp in my answer, and after that we have just updated our temp. This is what I have already explained you. Okay, now let us call the same for root.right in the end, pass temp and then answer. From here we can just simply return, and that's it. That's all about the code that we needed to do. So let's take a quick example to run our code as well. So let us say the root node is nothing but node 15. The left child of node 15 is, let's say, node 5, and the right child is node 25. Okay, now the left child of node 5, that is root.left.left, is nothing but node 2. So I'm gonna take a small example. So let's call this Inorder Predecessor functions and pass the root node in it. Let us check the output of our code. So the output of our code will come in the form of tree node, but still let us check it. So the output of the code is coming out to be first value is null, which is indicating that we are going correct, and all the values are in the form of tree node. Why in the tree node? Because we are not adding here the value, we are adding the node itself. You can also add the value here, but in that case you need to handle one case, that if the current temp value is null, in that case the tree node will it will not be an object of tree node. So you need to handle it using an if condition. Okay, I hope this was clear. This was pretty easy, nothing much. Okay, I hope the solution approach, I hope the problem statement, the solution approach and the code made sense to you guys. If you guys still have any queries regarding this problem, please drop your concern in the comment section and I will be more than happy to help you there. Regarding this series, I will be uploading more of the questions in the upcoming weeks, so keep following us. Until then, keep smiling and keep coding. Thank you.